Forces and vectors, algebra 2 trigonometry regions. So this is the end of a chapter that focused on the law of sines and law of cosines formulas. And that's basically what we're going to be using here is those two tools. That the law of sines and law of cosines can be used to find side and angle measurements of triangles. And that's kind of what we're going to be forming here. Now, these questions don't say here's a triangle. You kind of have to draw triangles based on these pictures that they give you, which are going to be forces, sometimes referred to as vectors. And a force or a vector is essentially like a ray. So if you remember back from geometry what a ray is something that looks like this. That it has a starting point and then it goes out this way. This is a vector, also referred to as a ray. And we're going to be calling it a force. And basically the concept here is that if there are two forces from the same point, so here's force A and force B, and you can think of it as kind of like if there are two boats tied to a buoy in the water, and one boat drives off to the right this way, and another boat drives off in this direction up a little bit. What's going to happen to the buoy? Well, the buoy is going to actually travel between them this way. Now, by how much? Well, see how this vector here is a little bit longer? We would say that this one is stronger. So this is a stronger force, a stronger vector. And this is a weaker force, a weaker vector. And so the result of the buoy is it will tend to be pulled in between them, but not not directly between them, be pulled a little bit towards the stronger vector. And we call this the resultant. The resultant is basically the result of two forces acting on a body and the path that that body would travel and the force of which that body would travel. So that's kind of what we're talking about when we say two forces. Now, of 40 pounds and 28 pounds, that's basically their strengths, their magnitudes. And we can kind of think of that as like the length of this side. Because what we're going to be doing is we're going to be forming pictures out of this that eventually will turn into triangles. So let me first just read this first problem for you. Two forces of 40 pounds and 28 pounds act on an object. So let's draw that picture. That picture would be, let's say this is one force of 40 pounds and then another force of 28 pounds. And the angle between the two forces is 65 degrees. And so I'm going to set it up like that. That looks like it's about 65 degrees. And so this force right here, down here is, let me just tap a pen. If I could get that to work. Hold on one second. So this stronger force is 40 pounds, and the weaker force over here is 28 pounds, and the angle between them is 65 degrees. Now, all of these force vector problems are going to be set up the same way. They are all going to be set up something like this. We may not give you these exact measurements, but what happens is they want to find the magnitude of the resultant. Now, the resultant would be this in here. But what we end up doing is every time we have a force vector problem like this, we end up drawing a parallelogram. And so that's kind of the picture that we create here. Let me clone this and move it over here. And then also clone this and move it up here. And then the resultant is the diagonal of that parallelogram. So every force vector problem we have, it's going to give you two forces, and there's going to be a resultant, and the resultant is the diagonal of the parallelogram created by these two forces. And we know that a parallelogram cut by a diagonal creates two triangles. So this is one of the triangles, and that's really what we're going to focus on here. Now, the other thing is when you have a parallelogram, if you remember some of the parallelogram properties, that opposite sides are congruent in a parallelogram. So this force of 28 is also over here. And this force of 40 is also up here. And now this angle of 65 is this whole angle of 65. And that's the same thing for over here. And then the other thing about parallelograms is that adjacent angles are supplementary. So if this is 65, 180 minus 65 means that this angle is 115, and this angle is 115. And that's most likely the angle I'm going to be using, because the problem with the 65 that they gave us between the two forces is it's a angle of the parallelogram, the whole parallelogram. It doesn't involve the diagonal. And I want to work with triangles when I'm doing law of sines, law of cosines. Now this 115, this is an angle in the triangle. 65 is not. 65 is this acute angle plus this acute angle, but not the whole thing. And we also get alternate interior. So if I did, sometimes they will give you the angle between the forces, like this angle right here. Well, that's going to be the same as this angle right here because of our alternate interior property from geometry. So that's how you're going to set up a lot of these problems, that they're going to talk about two forces and a resultant and stuff like that. You basically draw a parallelogram with a diagonal drawn. And then if they give you the lengths of the forces, put those in two spots. If they give you the angle between the force and the diagonals, they go in two spots also. If they give you the angle between the forces, really what they're trying to do is hint to what this angle needs to be, because these two angles are supplementary. And that's really what we need. Because to find the magnitude of the resultant, the length of this diagonal here, that's x, I need to do my law of sines, law of cosines. And let's see what would be the proper formula here. So first of all, let me just emphasize this triangle one more time, that we're looking at this triangle down here. Or I could use the top one because it's the same thing. But I'm going to go with this bottom one. And I have a side measurement of 40, another side measurement of 28, and an angle measurement of 115 between them. And I'm looking for this side measurement, the resultant x. The question is, can I do law of sines? Well, I have the side of 40, but the angle across from 40 would be over here. I do not have that angle measurement, so that's not a complete set. I have the side of 28, but the angle across from it's not the 65. The angle across from it is just this part, so it's part of the 65. I don't have that exact angle measurement, so I cannot use that complete set. I have the angle of 115, but not the side across from it. That's what I'm looking for, the resultant. So I have no complete set, which means that law of sines is not an option here. I must do law of cosines. And the law of cosines is you find a side squared equals the other two sides squared, so that would be 40 squared plus 28 squared minus 2 times those other two sides, 2 times 40 times 28, and cosine of the angle opposite the side you want, so cosine 115. And from here, it's a lot of calculator work. Let's see, we got 40 squared plus 28 squared minus 2 parentheses 40 close parentheses open parentheses 28 close parentheses cosine 115, and that is that whole number. But remember, that's not x, that's x squared. So x squared is approximately 330 and 33 3330.664. So let me go back to that. 3330.664. Where so x squared equals 3330.664. But I'm going to do the square root of both sides, and that's going to get me x, and we're looking for it to the nearest degree, which is oh, there's two questions here. To the nearest pound for this one, and so I'm going to have to do the square root of my answer is 57.7, so that'll be 58. So 58 pounds, and that is the answer here, that this is now 58. And so that was actually, this is actually a two-part question here. Using this answer, find the measure of the angle formed between the resultant and the smaller force. Now the smaller force is the 28, so that would be this angle here, or if I'm using this bottom triangle, this angle here. So if I want to make this, say, y, the variable y. I can do law of cosines again, or now I can do law of sines because I do have a complete set with this side and angle across. So the 58 is my side. The angle across is 115, so sine 115. And that'll be, if I want this angle, the side across from it is the 40 over sine y, and then the rest is done in my calculator. And let's see here. Oh, I didn't want that. We'll do 40 times sine 115 divided by 58. We're finding an angle, so we have to do second sine, second answer, and we're getting 38.6 to the nearest degree would be 39 degrees. So angle Y is 39 degrees. Now, this technically would be an ambiguous case here, but supplementary with 39 is going to be 141. Paired with my 115 is definitely way too big, so this is my only real option, but you should take a look at that because we know about the ambiguous case. So these force vector questions, this could be a part 4. This could be the most point question on the Regents exam. And basically, when you see two forces, vectors, resultants, draw a parallelogram. Almost every information goes in two spots. All angles go in two spots. All sides go in two spots. The only thing that doesn't go in two spots is the resultant. That's just the diagonal stays in one spot. And you're going to have to determine law of sine, law of cosines to find what you need. But it's going to take some practice, and that's what we'll do tomorrow.